Hi, my name is Tiana Dummett, and this is my presentation on probability and binomial distribution, which is Math Section 3, and it covers pages 31 to 38 in the resource guides. So this just for a review, I just wanted to review from the last section. This is called the N choose K formula, and it is used for finding combinations. So this gives us a way to select K objects out of a group of N objects, and it's read aloud as N choose K. So N choose K is equal to N factorial over K factorial times the N minus K factorial. And you should have learned in the last section that factorial, let's say an example of a factorial would be 5 factorial is 5 times 4 times 3 times 2 times 1. So for an example, how many 5-member groups can we choose out of 40 members? So we're choosing 5 out of 40 people. So we can write this as 40 factorial times the k factorial, which is 5 factorial, times n minus k, so 40 minus 5 is 35 factorial. And the key to solving factorials is actually that stuff cancels out. So on the top, it goes 40 times 38 times, or 40 times 39 times 38 times 37 times 36 times 35 all the way down. Whereas this right here has 35 times 34 all the way down. So that ends up canceling out with a lot from the numerator. And if we solve this all out, we should get 658,008. So equally likely means that each outcome has the same chance occurring as any other outcome. The probability of an event occurring when all outcomes are equally likely is the number of ways that the event can occur divided by the total number of outcomes. So an example is that the probability of rolling a 4 on a 6-sided dice is 1/6 because there's only one of those 6 possibilities in which we can get a 4. And there are 6 total outcomes, so 1 divided by 6. So what if we want to know the chance we have of getting 3 heads and 2 tails when we flip a coin 5 times? So we could list out all the possibilities with heads and tails like that, but this would take too long, and we can actually use the N choose K formula to determine how many different ways this can occur. So we are placing 3 H's or heads in 5 spots. So 5 choose 3, sorry, this is written a bit weird, is equal to 5 factorial over 3 factorial times 5 minus 3 factorial. And 5 minus 3 factorial, which is 2, is actually just 2 because 2 factorial is just 2 times 1. So here on the top, we have 5 times 4 times 3 times 2, all over 3 times 2 times 2. And in factorials, like I said earlier, a lot of stuff ends up canceling out. So this 3 cancels out with this 3, and this 2 cancels with one of these 2's. So we're left with 5 times 4 over 2, which is 20 over 2, or 10. So that means that there's 10 different ways in which we could get 3 heads and 2 tails when the coin is flipped 5 times. Now we want to divide this number by the total number of ways in which we could flip a coin 5 times. So to figure that out, we use the multiplication formula, which I believe is also covered in the last section. So if you think each time the coin is flipped, there's 2 possibilities you can get. And we're multiplying this 2 times 2 times 2 times 2 times 2 because we're flipping it 5 different times. So 2 to the 5th power, which is equal to 32. And so our final answer is just going to be this divided by this. So 10 over 32, which we can rewrite as 5/16. So next question is, what is the probability of being dealt a 4 of a kind in poker? And we're also going to use the same N choose K formula for this. So, and this is an equally likely problem because every card you get has an equally likely chance of getting drawn. So we need to count the total number of poker hands that could be dealt to you. And in poker, you're getting dealt 5 cards out of 52. And we also need to count the total number of poker hands that can get us 4 of a kind. So how many poker hands are possible? So we're getting 5 cards out of 52 cards in the deck. So that is 52 choose 5, which is 52 factorial over 5 factorial times 47 factorial, which a lot of stuff cancels here as well. And I rewrote it as 2,598,960. So that's how many possible poker hands could be dealt to you. So now we need to count the total number of that number of total poker hands that can get us 4 of a kind. So there are actually 13 different 4 of a kinds we could get, because we could get 4 2s, 4 3s, 4 queens, any of these right here. But in poker, you're getting dealt out 5 different cards. So 4 of them are going to be your 4 of a kind, but what about the 5th card? So that 5th card doesn't matter what it is, it could be any of the remaining cards, and doesn't matter what it is, you'll still have 4 of a kind. And the reason it's 48 remaining cards instead of 52 is because 4 of the 52 cards are in your deck, so there are 48 cards that could be put here. So for each 4 of a kind, there are 48 different hands you could get, and there are 13 different 4 of a kinds that we could get because of these. So the total number, we can multiply these together, is 48 times 13, which equals 624 different hands of 4 of a kind. So the probability of being dealt a 4 of a kind in poker is 624 over 2,598,960, or 1 over 4,165. So now I'm going to talk about binomial distribution. So an event with n outcomes has p that are considered a success and q that are considered a failure. If this event is repeated r times, the probability of getting s successes and f failures is given by this formula here. R choose s times p to the s times q to the f all over n to the r. And then note that p plus q equals n, and s plus f equals r, and this looks really complicated, but we'll see it in the next example. So the next example is if you randomly guess on a 20-question science quiz, multiple choice with 4 options for question, and one of those 4 options is correct, and the other 3 are incorrect. What is the probability that you will get at least 12 out of 20 on this quiz by purely guessing? So if we have n outcomes and p considered a success, q or a failure, so think our event here is actually just a question on the quiz. So each question has 4 different outcomes, and only one of those is a success and q is a failure. So n is 4, p is 1, and q is 3. And if this event is repeated r times, so it's getting repeated 20 different times because we have 20 questions, so r is 20. And we want to know the probability of getting 12 successes, 12 right, so s is 12, and f failures, 8 failures. And as you can see here, p plus q is n, 1 plus 3 is 4, and s plus f is r, 12 plus 8 is 20. So we're going to plug all these into the formula here. So 20 choose 12 times 1 to the 12th power times 3 to the 8th power, all over 4 to the 20th. And we know that anything that 1 to any power is always going to be 1, so I'm just going to get rid of that there and rewrite it as 20 choose 12 times 3 to the 8th, all over 4 to the 20th. And total, that's a pretty big number. The final answer is this, which is not a great probability. Seems like a big number on the top, but it's actually very unlikely that that will happen. But this question actually asks for getting at least 12 out of 20 correct, not exactly. So this shows us the exact probability. This is all the solutions that will get us exactly 12 out of 20, but we want to know 13 out of 20, 14 out of 20, or even 20 out of 20. So we would actually need to add up all the possibilities in the numerator to get our final answer. But I'm not going to do that now. You can do that on your own because it will take a while. And I looked at the practice test for the math in Aca Deca, and a lot of the problems are more for speed than long questions like this. So you will need to know binomial distribution and n choose k formula and probability. But I don't think that there's going to be super long problems with crazy numbers like this on the actual Aca Deca test. All right, that's all for my presentation. I hope you guys enjoyed, and please email me if you guys have any questions.